Welcome Protege. Today we're going to show you how to interface a 16 key keypad with a 10 segment LED bar graph to an Arduino Uno Rev 3. Now for this project you'll need a breadboard, a 16 key matrix keypad. This has keys 0 through 9, letters A, B, C, D, and symbols asterisk and the pound sign. I have some short jumpers to be used on the breadboard, and I have a couple of resistor arrays. One is 1.2K and the other is 470 ohms, which are both included in the Modulus kit. And then I also have some male-to-male 8-inch jumpers, so we can jumper from the breadboard to the Uno Rev 3. Now first we can start by placing the keypad on the breadboard. The keypad has 8 pins, 4 columns and 4 rows, and usually on the packaging it shows you the pinout. So here you can see the 4 columns and the 4 rows, and then their corresponding pins. For example, column 1 is pin 1, column 2 is pin 2. Next we want to place the 1.2K ohm resistor onto the breadboard, and this is to avoid floating input pins on the Uno Rev 3. Then you want to ground pin 1 of the resistor array, because these will be used as pull down resistors. And next we can place the LED bar graph. Similar to project 1, you have to be cautious of the orientation of the LEDs. And make sure you place the LED bar graph over the valley of the breadboard. So we have the indent of the LED bar graph in the top right corner. And for this we want to use the 470 ohm resistor to provide a series resistor to each LED, which helps limit the current. And similar to the resistor array that we used on the keypad, we also want to ground pin 1. Next we want to add a pull down resistor to each row on the keypad. And now we can start placing the male-to-male jumpers. First I'll place 4 wires on the column pins of the keypad. And these will be outputs on the Arduino Uno. Then place male jumpers on the row pins, and these will be inputs to the Uno. And then we can place jumpers on the anode side of each LED. Now LED 1 is all the way on the right, so this we'll be using LED 10, 9, 8, and 7. So go ahead and place a jumper on each anode of those LEDs. Okay, so we have the wiring all done on the breadboard, and now we can hook it up to the Uno Rev 3. I already have the Uno hooked up in the prototyping area of the fuel can. I have the type A to type B cable plugged in to provide power and to be able to program the Arduino. First I'll start with the column pins on the keypad. So we want column 1 to go to pin 0. Next I'll hook up the row pins on the keypad to pins 4 to 7 on the Uno, and these will be inputs. Okay, we have the keypad all plugged in, and now we can hook up the LED bar graph. I mentioned earlier that we'll be using LEDs 7 through 10. So LED 7 will route to pin 8. LED 8 will route to pin 9. LED 9 will route to pin 10, and LED 10 will route to pin 11. So now we have the hardware complete. Next we'll jump to the software. Now we have all of it written, but we're just going to go through it so you better understand it. First up, we have our variable declarations. We have a variable for each key on the keypad, and we initialize those to 0. Next we have our void setup and void loop, which are required by the IDE. For void setup, this is what you run once, and this is typically where you set your pins as input or output. So on pins 0 to 3, those are outputs, and 4 to 7, those are inputs. And with just this one line of code, we can set that whole port. For example, if we set the pin to a 1, then that will be set as an output, and if we set the pin to a 0, then those will be inputs. So this one line of code will set pins 0 to 3 as output and pins 4 through 7 as input. Next we have to set pins 8 to 11 as output, which we use with a function called pin mode, and that accepts two arguments. The first argument is the pin number, and the second argument is either output or input. Next we have our loop function, which is what we run repeatedly. So first off, we set column 1, which is connected to pin 0. We set that high, and then we check buttons 1, 4, 7, and AST, which is for asterisk. Now to read these 4 buttons, we do a digital read on pin 4, 5, 6, and 7 respectively. And then once we do those button checks, then we set the column 1 low. Next we have a set of if statements where we check to see if a button within that column was pressed. For example, if button 1 is equal to 1, that means it was set high, and we set the LEDs to 001, which corresponds to high, low, low, low. Once we do all 4 of those button checks, then we set column 2 high, and we check buttons 2, 5, 8, and 0. And then we have the if statements that set the LEDs accordingly if that button was pressed. Then we set column 3 high, which is on pin 2. Read buttons 3, 6, 9, and hash, and then set column low. Then we have the if statements for those buttons. And finally we set column 4 high, which is on pin 3. And then we check buttons A, B, C, D with the 4 if statements below.